Hey guys, here's the review for your midterm. I'm going to go through a selection of problems from the midterm review and try to do one or two from each topic so we have something to work from. First up, we're looking at graphing inequalities. Now, this is going to be a multiple choice question on your midterm, but we need to understand the principle for how these things work before we can get there. And what we're going to do is graph each of these separately. I'm going to graph that one in purple and that guy in red, and then deal with the inequality part of that afterwards. So for the first one, we've got a y-intercept of -3. We've got a slope of 1, so I'm going to go up 1 over 1, up 1 over 1. And because we're dealing with a less than and not a less than or equals, I'm going to make a dashed line going through this point. On a multiple choice question, the first thing that I want to do is to see if I have any graphs that don't show this line at all. If this line is not there, that can't be an answer. That's a great way to cross some things off. Okay, next thing I'm going to do is to check the point 0, 0. It's not on my graph, so I can use that. And I get 0 is less than 0 minus 3, which is false. If it's false, I'm not going to color on that side of my line. In fact, I'm going to color on the opposite side. So that'd be this side of my graph. Okay, second line, I'm going to look at y is less than or equal, -4x plus 2. I'm going to use my y-intercept of plus 2, down 4, 1, 2, 3, 4, over 1, down 4, 1, 2, 3, okay, I'm off my graph now, so somewhere down there. Less than or equal means a solid line, and I'm going to go up like this. And again, I'm going to make sure that I'm looking for graphs that have both of these lines on them. Sometimes you can get to an answer before you actually finish the problem. Okay, and similarly, I'm going to look for plugging in my origin. So we've got 0 is less than or equal to 0 plus 2. That's true. That means I'm going to color in that side of this graph. So that's this part over here. And this is my final answer, where I can see where both of them are shaded and the parts that only one of the two graphs are shaded. You'd be looking for this picture on a multiple choice question. Here we're doing some factoring. I'm going to look at this in two different ways. The first is doing this forwards, and the second is if you can't remember how to factor, we need a way to solve this problem. Okay, so doing this forwards, we're looking for a times c, things that multiply to 28v squared, and also add up to -11v. Okay, 1 times 28, no. 2 times 14, no. 3 doesn't work. 4 times 7, that's 11. -4 times -7 is what we're looking for. Okay, so that'd be 2v squared minus 4v minus 7v plus 14. I look at my first two, they can take a 2v, and I'm left with v minus 2. For the next pieces, I can divide out a -7, and I'm left with v minus 2. That gives me v minus 2 and 2v minus 7, which happens to be answer choice D. If I don't remember how to do that, one of the things that I could do instead would be to multiply these pieces out. So, for example, 2v plus 7 times v plus 2, that would be 2v squared plus 4v plus 7v plus, I was about to say 9, but that's plus 14, which does not give me the same thing as my original question. That one doesn't work. I could do the same thing for each of these answers, and in that process, instead of actually factoring, I could multiply to see which one gives me the right question. Here we're looking at operations with complex numbers. Realistically, this is just combination of like terms. And what I'm going to do is take -6i and go minus -8i, and -6 minus -8, so -6i minus -8i, is positive 2i. And then negative 3 minus 7. So negative 3 minus 7 is negative 10. The answer here would be negative 10 plus 2i. Again, just combination of like terms. To write a polynomial function of least degree using zeros, what we have to remember is that if a is a 0 or a root or an x-intercept, what that really means is that x minus a is a factor. So to write a polynomial, what I'm going to do is take each of these and go, instead of 1, x minus 1, instead of negative 2, x minus negative 2, and instead of 2, x minus 2. If you wanted to rewrite this, you could as x minus 1, x plus 2, and x minus 2. You could multiply this out, but we're probably not going to ask you just for the sake of time. And by probably, I mean we're not going to ask you to do that just for the sake of time. Here we're looking at some properties of exponents. I'm going to handle this in two parts. First, I'm going to deal with that 2 in the exponent outside the parentheses, and then combine what I can. This is also the part that's going to trick you in terms of the problem. So that 2 is going to go to each exponent here. We know there's really a 1 hiding on the 2 in front of the problem. 1 times 2 is 2, so 2 squared. 4 times 2 is 8. 2 times 2 is 4. And I'm just going to carry that a to the third down. Okay, 2 squared is 4. And you might notice that the only one of these that has a number out front that's 4 happens to be c. So you're done with the problem if you figure that out. Or you can keep going. A to the third times a to the eighth. 8 plus 3 is going to be a to the 11th. And then we've just got b to the 4. And again, that's going to be choice C. With the polynomial operations, we know we have to do some distribution here. I've got multiplication between them. So we've got 5x times 3x squared, that'd be 15, and then x to the third. 5x times negative 6x is going to be negative 30. And then x squared. 5x times minus 3 would be minus 15x. Negative 6 times 3x squared is minus 18x squared. Negative 6 times minus 6x is plus 36x. And negative 6 times minus 3 is plus 18. I'm going to combine some like terms. Nothing goes with x to the third, so I've got 15 x to the third. With negative 30x squared, I've got negative 18x squared, so it's minus 48x squared. With minus 15x, I've got plus 36x, so that's plus 21x. And then I've got plus 18 all by itself. Next up, we got a factor completely. This is quadratic-like because I go from 4 to 2 to 0. And for that, I'm going to treat this as though it were quadratic. So a times c, we get negative 3x to the fourth. I'm trying to add up to b, which is 2x squared. Negative 3 is going to be negative 3x squared and positive 1x squared. No, that goes to negative 2. How about positive 3x squared and negative 1x squared? If I add those together, I get 2x squared, so that's my winner. So we rewrite as x to the fourth plus 3x squared minus 1x squared minus 3. I'm going to factor this by grouping. The first pieces, I've got an x squared in common. That leaves me with x squared plus 3. And for my second pieces, I've got a minus 1 I can take out of both. And that leaves me with x squared plus 3. Okay. Finally, it's going to give me x squared minus 1 and x squared plus 3. Okay, I'm going to go look for my answer. X squared minus 3x squared plus 1. No. Okay, that's 3 pieces. I don't see it. I also know that that doesn't work for my last one. But that's because x squared minus 1 is factorable again. X squared minus 1 factors into x minus 1 and x plus 1 because of difference of two squares. Or if you wanted to factor that out, you could. X squared plus 3 would be my other piece. So in fact, we're looking for choice B. You might also have gotten that if you saw that this has x squared minus 3, which doesn't work in our function either. Once again, if instead you wanted to go forward with this instead of factoring, so x squared minus 3 and x squared plus 1, do some double distribution and see which one gives you the question. That's totally okay here. It's not what the question's asking you to do, but it is a way to solve this problem and get credit for it. Here we've got a combination of like terms. I'm going to start with my first piece, k, and I'm going to look over here. I've got minus 5k. K minus negative 5k is going to be positive 6k. 2k squared minus k squared is going to be 1k squared. And then negative 2k to the third minus negative 2k to the third cancels out. That would give me 0 as an answer. We're going to solve by factoring. In this case, there are not any good numbers for me to divide by that all these are divisible by, so I've got to do this the long way. The first thing to do is do 25 times negative 32. That's my A times C number. And 25 times 32, negative, is going to be negative 800. So I'm looking for things that multiply to negative 800 and add up to negative 20. So I'm going to start with things that are pretty close together. For example, 10 times negative 80, give me negative 70. Not really what I'm looking for. Okay, how about 20, and that's times negative 40. And wow, that actually worked. I got the second try, which was better than I was expecting when I'm trying to multiply negative 800. Okay, so in doing this out, we're going to go with 25x squared plus 20x minus 40x minus 32 is equal to 0. Okay, first two have a 5x in common, and I'd be left with 5x plus 4. The next two I can divide by negative 8, and I'd be left with 5x plus 4. We've got a winner. I love when that happens. That gives us 5x minus 8 multiplied by 5x plus 4 is equal to 0. Okay, in other words, 5x minus 8 is equal to 0, which means that x is equal to 8/5, and 5x plus 4 is equal to 0, which means that x is equal to negative 4/5, which happens to be answer choice D. As an alternative, if you can't figure out the answer for this, if you plug these numbers in and both of them are give you answers that you're looking for, that would be the right answer. So for example, if I did 25 3/2 squared minus 20 3/2 minus 32, and that equaled 0. And if I plug that into my calculator, I find out that that doesn't work. That does not equal 0. That eliminates that answer. I can do the same thing for B and do 25 negative 1/7 squared minus 20 times 1/7 minus 32 equals 0. And if I try to plug that in, I also get that doesn't work. By the time you got to D, you'd find out that the other three answers didn't actually work pretty quickly. And if you didn't feel like factoring or couldn't remember how to factor, that's another way to approach that problem. All right, here we've got another quadratic to solve. And in looking at this, if I look at my answer choices, I notice something. All four of those answer choices look awful. This is pretty clearly not something that I can do by factoring. Factoring gives me nice looking answers. These are not nice looking answers, which leaves me with either completing the square or the quadratic formula. I'll do that both ways just to see how both of them turn out. So we've got a squared plus 10a plus 50 is equal to negative 8. Okay, for completing the square, I'll do that in blue. First thing I'll do is clean things up. Let's get rid of this minus 50. So we got a squared plus 10a is equal to negative 58. All right. Then we've got a squared. We've got to split this up into two equal pieces. Plus 5a plus 5a is equal to negative 58. And to figure out what I'm going to add to both sides, I'm going to take these two and multiply them. So it's going to be plus 25 and plus 25. Okay? This is going to factor into a plus 5 squared. And on the left side, negative 58 plus 25 is going to be negative 33. I'll take the square root of both sides. And that's going to be a plus 5 is equal to plus or minus. To get that negative out of there, I'm going to write this as 33i. And already you might say, Mr. Carlson, that looks like it's going to be d, and you'd be right. But just to finish this up, we're going to minus 5 from both sides and get a is equal to negative 5 plus or minus the square root of 33i. Okay, using the quadratic formula, we'll do in purple. We've got to make this equal to 0 first, so we'll bring everything over to one side. So a squared plus 10a plus 58 is equal to 0. So we've got negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. If I plug those values in, you've got 1 for a, okay, so that's going to be 2 and 2. Negative b, so negative 10. And within here, we're going to have 10 squared is 100. Minus 4 times 1 times 58. Oof. All right, so we've got negative 5 plus or minus the square root of 100 minus 4 times 1 times 58. What? Well, 4 times 58 is going to be 232. 100 minus 232 is going to be negative 132. And that's going to be equal to negative 5 plus or minus. I can pull a 4 out of this guy because negative 132 is equal to negative 33 times 4. Square root of 4 is 2. Square roots of negative 33. Okay, now this is looking more familiar. My 2's cancel out, and I'm left with the same answer I had before. I kind of like completing the square better because we don't have that reducing to go on at the end, although quadratic formula will get you to an answer faster. All right, we got to find all zeros and then sketch a graph. Zeros, in other words, x-intercepts, happens when we multiply to get 0. So we've got x is equal to 0. We've got 3x plus 5 is equal to 0, and we've got x plus 3 is equal to 0. Plotting those, we're going to have 0. This would be negative 5/3. And that's going to be somewhere bigger than 1 and less than negative 2. And then we're going to have negative 3 as our third 0. Okay. Other stuff that I might use from this. This is a positive graph, and I've got 1, 2, 3 pieces. So we're looking at degree 3. And we're looking at a leading coefficient of positive value. So at the end, our graph's going to go up. That suggests that if we kind of loop through, we end up with something that looks like this. Next up, we got to write a quadratic function in vertex form that has the vertex and passes through this given point. There are two things that you've got to remember. The first is what vertex form actually looks like, and that's y is equal to a x minus h squared plus k. Okay. Vertex is 2, 3. That goes into those places. So we've got y is equal to a times the quantity x minus 2 squared plus 3. I'm going to take my first swipe at my answers now, cross out anything that doesn't work with this. D has a minus 3. The other three have plus 3s, minus 2 on the inside. A's got 5x minus 2. We're down to just B and C. Okay. Next step is I've got to solve for A, and to do that I'm going to use the point that they give me. So negative 24 is equal to A, 5 minus 2 squared plus 3. Negative 24 is equal to A. 5 minus 2 is 3, squared is 9, and then plus 3. I'm going to subtract 3 to both sides. Negative 27 is equal to A times 9. A is equal to negative 3. Okay, that goes back into my equation. Y is equal to negative 3. X minus 2 squared plus 3. That happens to be choice B. We've got to graph a quadratic. We talked a lot about doing this with tables or doing this based on some information in the problem. Let's talk about the table first. Ideally, we set our table centered around whatever the middle number is, and that's going to be 6. Whatever makes the parentheses equal to 0. If I plug that in, I get 6 minus 6 is 0, squared is 0, plus 1 is 1. All right, 6, 1 is my first point. I'm going to go up and down, and then up one more and down one more. 7 minus 6 is 1, squared is 1, plus 1 is 2. It'd be 7, 2. And then if I go to 5, 5 minus 6 is negative 1. Negative 1 squared is positive 1, plus 1 is 2. I get this nice symmetry that we should be expecting. 8 minus 6 is 2, squared is 4, plus 1 is 5. So we're looking at 8, 5, and then 4 end up at the same height, which gives me a graph that looks something like this. The vertex for this graph was at 6, 1. You can get this either from graphing or by looking at this form and realizing that the x-coordinate is the opposite of what's inside. The y-coordinate is that number, so 6, 1. Here we've got a rational exponent. I'm probably going to rewrite this first as a radical. Don't worry, I'll show us a nice quick way to do this in a minute. So that 3 goes in the index, and I've got 64. I tend to like things making them smaller first, so I'll put the squared on the outside. Okay, now I've got to do some reducing. I'm looking for something that multiplies by itself 3 times to get 64. Since 4 times 4 times 4 is 64, that's going to be 4. Now I've got to square that, and the answer for this is 16. This happens to be a calculator active test, which means, to be honest, it's kind of a dumb question. Because if you were to type 64, and then whatever button gives you some exponents on TI, that's the caret button, parentheses, 2 divided by 3, close parentheses, it will give you 16 as the answer. Just saying. You got to be able to divide using synthetic division, and you got to be careful while doing this that you don't lose track of coefficients. First thing is the setup. For x plus 9, we use the 0 for that. That'd be negative 9 on the outside. I'm going to make sure that I don't lose any power, so 4, 3, 2, 1, number. Cool, we're good there. My coefficients, 1, negative 97, negative 62, and 2. Bring the first one down. Negative 9 times 1 is negative 9. Add them up, I've got negative 10. Negative 9 times 10 is positive 90. Add them up, and I've got negative 7. Negative 9 times 7 is positive 63. And if I add those up, I get positive 1. Negative 9 times 1 is going to be negative 9. Add those up, and I get negative 7. The result of this, there's my remainder. So that'd be negative 7 over x plus 9. And to that, I'm going to add a 1. And then negative 7x, negative 10x squared, and 1x to the third. You see how we started on the fourth power, we ended up on the third power? If you wanted to start from the front side, you could. I tend to start from the back at those. And there are times that you can't use synthetic division, you've got to use long division. This is a particularly heinous example of one, and that's okay. We're not going to shy away from those. But we're going to write this as x squared minus 3x minus 1 out front. It's our divisor, and on the inside, the dividend, it's going to be 8x to the fourth minus 2x to the third plus 12x squared minus 6x plus 4. To get from x squared to 8x to the fourth, it's going to be 8x squared, which means I get 8x to the fourth minus 24x to the third minus 8x squared. And then if I go to subtract those, I get 0. I get 22x to the third, and I'm going to end up with 20x squared. Probably bring down my minus 6x just to see if I need that for the next piece. To get from x squared to 22x to the third, that's going to be plus 22x. Multiply this down. We end up at 22x to the third minus 66x squared and minus 22x. When I go and subtract, I get 0. I get positive 86x squared, and I get positive 16x. Bring down my 4. Finally, I'm going to look at my last piece. So from x squared to 86x squared, it's going to be plus 86. That's going to be 86x squared. 86 times negative 3 is going to be negative 258x. And 86 times negative 1 is negative 86. When I go to subtract, I get 0. I'm going to have negative 242x, and I'm going to have negative 82. Since I can't go any further with that, that would end up being my remainder. So it would end up being plus a negative 242x minus 82 all over x to the third minus 3x minus 1. So x squared minus 3x minus 1. Sketching a graph of absolute value. Again, I'm going to start off with making a table, and I'm going to choose whatever makes that equal to 0. So it's going to be negative 3. That's my middle value. Let's go up a couple and down a couple from there. I only need 3 values for this time, but I'm going to do 5 anyway just to make sure. So negative 3 plus 3 is 0. Negative 0 is still 0. Minus 4 is negative 4. That's my first point. If I do negative 2, negative 2 plus 1 is going to be 1. I'm sorry, negative 2 plus 3 is 1. Absolute value is still 1. Negative makes it negative. So negative 1 minus 4 is negative 5. If I go up another one, negative 1 plus 2 is 2. Absolute value is still 2. Negative 2 minus 4 is negative 6. If I go to negative 4, Negative 4 plus 3 is negative 1. The absolute value makes it positive 1. The negative up front makes it negative. Negative 1 minus 4 is negative 5. If I plug negative 5 in, I'll get negative 6 is the answer. This graph is going to look like this after I plot these points. We got a rational root theorem problem. I'm going to start out by listing the rational zeros. That's going to be factors of the last divided by factors of the first. Divided by 1 just gives me whatever I started with, so let's do factors of the last number. I'm going to plus 1 minus 1 plus 24 minus 24 plus 2 minus 2 plus 12 minus 12 plus 3 minus 3 plus 8 minus 8 plus 4 minus 4 plus 6 minus 6, and that's it. Oof, nice. Oh, look, I gave you one of the zeros already. How nice of me. Let's synthetically divide that. So 1, 1, negative 14, negative 24, and just reminding ourselves that we did x plus 2, because that's what negative 2 means, is a root. 1, negative 2, negative 1, that's going to be positive 2, negative 12, 24, and 0. It certainly does work. That means that we're looking at x plus 2, that's what we divided by, and that's x squared minus 1x minus 12. This guy factors, so that's x plus 2 out front, and this would factor into x minus 4 and x plus 3. That's my final factored form. Zeros are going to be at x equals negative 2, x equals 4, and x equals negative 3. Here we go, Mr. Powers. Mr. Bankell buying notebooks and calculators. Mr. Powers buys 4 notebooks and 2 calculators. And total of 38. This sounds like a system of equations problem. I wonder if it is. So that'd be 4 notebooks. I'll just use X for notebooks. Plus 2 calculators. I'll just use Y for calculators. Equals 38. Mr. Bankell buys 6 notebooks and 3 calculators for 57. 6 notebooks plus 3 calculators is equal to 57. All right. Write an equation for Mr. Powers purchased using the number of notebooks and the number of calculators as your variables. Because I made something stupid with this equation, I'm going to change this to $60. Okay. You don't need to worry about why I'm doing that, but this doesn't come out so nicely if you don't do that. Write an equation for Mr. Bankell's purchase. Oh, we already did that. Determine the cost of the calculators and the cost of the notebooks. I've got to solve this system of equations. This is still going to be awful, but that's okay. So you've got 4x plus 2y equals 38. And we've got 6x plus 3y is equal to 60. It just so happens that if I multiply the top of this by 1.5, I end up getting 6x plus 3y is equal to 57. Now if I go to subtract these two equations, I get 0 is equal to 3, which means that there's no solution. Hurrah! All right, now for graphing these guys, which is also going to be a little bit unpleasant, it might be easier to convert these to slope-intercept form. So if I take the first one, 4x plus 2y is equal to 38, I'm going to minus 4x to both sides, divide by 2, and I get y is equal to negative 2x plus 19. All right, so that'd be somewhere in there. And down 2 over 1 is going to give me a slope that comes in like this. Graph
Graphing in this is so much fun. So 6x plus 3y is equal to 60. Same thing. And over the y is equal to negative 2x plus 30. And if I graph that, oh man, those lines don't intersect. I wonder if I could have predicted that with anything that I had come up with before, like perhaps no solution? Huh. Parallel lines do not intersect, therefore we have no solution. Here's a nice freefall problem. We got Angel Falls in Venezuela, which, if you didn't know, is the waterfall in the movie Up. Is 3,212 feet tall. We've got a function that models the height in feet of an object t seconds after it is dropped. Okay, after how many seconds will the object hit the ground? The ground means y equals 0. So 0 equals negative 16 t squared plus 3212. Okay, I've got to solve for t. To get t by itself, I'm going to add 16t squared to both sides. 3212. I'm going to divide both sides by 16. And I get t squared is equal to t squared equals 200.75. I totally did that in my head and not on the calculator on my computer. That means I'm going to do the square root of both sides, and I get t is equal to plus or minus. And again, I'm totally doing this in my head, not in the computer. 200.75, 14.1686 seconds. Nearest tenth of a second, so that's 14.7 seconds. And I only really care about the positive one because we're talking about time, and negative time means seconds ago, not seconds in the future. What is the height of the object 5 seconds after it is dropped? In other words, when t is equal to 5. So y equals negative 16 times 5 squared plus 3212. Okay, well 16 times 5 squared is going to be negative 400. So we got negative 400. And that's plus 3212 is equal to 2812 feet off the ground. And finally, initial upwards velocity of 32 feet per second. How long will it take for the objects to hit the ground? So we've got a new lovely equation. So hit the ground is going to be 0 again. Negative 16t squared plus 32t plus 3212. I'm going to clean this up a little bit by dividing everything by negative 16. And we get t squared is equal to t squared plus negative 2t. And 3212 divided by 16, we already did once, minus 200.75. Not factorable, but I could totally complete the square for that. So t squared minus 2t is equal to 200.75. T squared minus 1t plus 1 is equal to 201.75. T minus 1 squared is equal to 201.75. The square root of both sides, and again, totally in my head, not from a calculator on my computer. I get the square root of 201.75 is 14.2, which means that t is equal to 15.2 by adding 1 to both sides. This should be plus or minus. Since we're dealing with time after we throw something, we only care about the positive version. Third word problem. Mr. Carlson, hey, that's me, is building a set of boxes to store his Legos, but I spilled coffee on my plans? That sounds terrible. This is what we know. The volume of the box. Okay, I'm going to draw a box. I am such a good artist. So the volume is going to be 72 inches cubed. The bottom of the box was square, okay? The bottom was 4 inches longer than the height, x. Okay, so the height is x. If the bottom is 4 inches longer, that'd be x plus 4. And if it's square, that would be x plus 4 also. I also know that volume is equal to the base, so x plus 4, times the width, x plus 4, times the height of x. Hey, I just accidentally answered the first part of the problem. Solve the equation for the specific volume of Mr. Carlson's Lego box. So that's that 72 number. 72 is equal to x plus 4 times x plus 4 times x. So in other words, 72 is equal to x cubed plus 8x squared plus 16x, and 0 is equal to x cubed plus 8x squared plus 16x minus 72. All right, to solve this, not factorable. I've got to come up with some alternative way to do this. That alternative way to do this might be to do some rational root theorem. Okay. So we're looking for numbers that multiply to get 72. 1, 2, 3, 4, 6, 7, 8, 9, and then I can work backwards. So you've got 12. Oh, why did I choose this problem? 18, 24, 36, and 72. Awesome. And when I go to try some of these things out, all these got to be plus or minus. I don't know. Let's try 2 perhaps. Or maybe negative 2. So that'd be 1, 8, 16, negative 72. 1, negative 2, that gives me 8, negative 2 is 6. Negative 12. 16 plus negative 12 is going to be 4, negative 8, and that does not work. How about positive 2? My original gut instinct. All right, we got 1, 2, 10, 20, 36, 72, and 0. Nice. So that's going to be x minus 2. And we've got x squared plus 10x plus 36 is equal to 0. All right, this one, that's when x equals 2. By the way, that's going to be our answer. For the other part, I'm going to zoom out a little bit and do some work over here. So now we've got x squared plus 10x plus 36 is equal to 0. I could either factor, not going to work, or complete the square, or do the quadratic formula for this. Let's complete the square. Minus 36 to both sides. We've got x squared plus 5x plus 5x is equal to negative 36. And that means I'm going to add 25 to both sides. X squared plus 5x plus 5x plus 25 is equal to negative 11. Means that x plus 5 squared is equal to negative 11. Square root both sides. We get x plus 5 is equal to plus or minus the square root of negative 11, which is an imaginary number. That's interesting. That means that x equals 2 is our only valid length for a side. You might notice that the second part of this question is how many real solutions are there? There's only one real solution. The other are imaginary, and those are numbers that just don't work for this box. What are the dimensions of Mr. Carlson's Lego box? Well, if x equals 2, that's my height. That means that x plus 4 is equal to 6. And if I do 2 times 6, I get 72. Hey, that worked. Oh, look, graphing piecewise functions. That sounds fun. We're going to start by looking at my boundaries. That's -1. When I'm less than -1, so we're on this side of my graph, we're looking at 2x plus 2. Okay, so there's y-intercept of 2, going up 2, down 2, back, back, back. And my line should look something like this. Since we're just less than and not less than or equal to, we get a hole at that boundary. For the other part, now we're on the right side of -1, -6. And we get a filled-in circle there. Oh, look, another graphing piecewise function. I'm going to start with my boundaries. So that's -4, -x, and that's going to happen where we're less than or equal to -4, so down here. Normally my line would look like this. Oh, that's positive. So let's go this way. But we only care about it after we get past the -4. And we should note that at our boundary we have a filled-in circle because that's less than or equal. All right, then we look at above -4, so x plus 2. I'm going to go like this. And that's an open circle at the boundary, with a solution to this graph that looks something like this. Function operations, I bet that's what people who are after school today are doing right now, or at least 2 of them. G of x is equal to 3x minus 3. H of x is equal to -x squared minus 5x. Looking for g minus h of x. In other words, I'm taking 3x minus 3. From that, I am subtracting -x squared minus 5x. And I'm going to combine like terms. 3x minus -5x is positive 8x. Minus 3 has no friends. We've got minus -x squared to make that plus x squared. And aside from a very lonely 3 with no friends, we are done. Here we've got g of n is equal to 2n plus 2. We've got h of n is equal to n squared minus 4. I'm looking for 3g plus 5h of n. In other words, 3 times g plus 5 times h, and then we're going to combine those like terms. So 3, and g is 2n plus 2. And then plus 5, and h is n squared minus 4. And we're going to keep this in n. So 6n plus 6 plus 5n squared minus 20. Since very little can be combined here, we are almost done. So 6n, 6 minus 20 is minus 14, plus 5n squared. Bada bing, we have an answer. H of a is equal to 3a minus 1. And here we're trying to find, oh, this is stupid notation, h of a. What the h? H is the function here. I'm probably going to start by rewriting this as h of a to make that a little bit more palatable. Now if I've got 3a minus 1 is h of a, I could rewrite this as 3a minus 1 inside that, so that's h of 3a minus 1. Another way to think about this is 3 times 3a minus 1 minus 1, where this is my variable that I'm replacing with 3a minus 1. So basically plugging the function into itself, which is kind of weird. So 9a minus 3 minus 1 is equal to 9a minus 4. Don't try this at home, that's dangerous. Last problem ever. So we got f of a is 4a plus 2, g of a is 2a. I want to divide these two and then plug in -3. In general, I'd like to think about this as f of negative 3 over g of negative 3. So that's going to be 4 times negative 3 is negative 12, plus 2 is negative 10. G of negative 3, 2 times negative 3 is negative 6. And that can be reduced to positive 5 over 3.